we are going to discuss gases, the types of gases we can say. Basically, there are two types of gases. First is ideal gas, or we say it a perfect gas, and this is a real gas, or we can say a non-ideal or imperfect gas. So these are two gases. One is ideal gas, second is real gas or the imperfect or the non-ideal gas. Now if we want to make this gas, like if we are having particle, we want to make the gas of these particle. What are the conditions we'll be giving to that particles? For example, particles are placed in a container. Like these are the particles that are placed in a container. Particles are placed in a container. Now what are the conditions that we will be giving to that particle so that it become a real or the ideal gas? We have to give a high temperature to it. We have to give a high temperature to it, and the pressure should be low. The pressure should be low. When we are giving a high temperature and the pressure is to be low, so there will be no volume. No volume would be there. There will be no volume, and there like when we are giving a high temperature to it, the particles will move far away apart from each other. When they are moving apart from each other, so the force of attraction, so there will be no force of attraction, like it would be decreased. There will be no force of attraction, and as we have given the high temperature, so the kinetic energy will be high, and obviously when kinetic energy is high, the potential energy will be low, and it will be not having a volume. But what are the conditions we have to give to make ideal gas? That is the high temperature and the low pressure, so we can make an ideal gas. Now if we talk about the real gas, non-ideal or the imperfect gas, what are the conditions we'll be giving to that particles to make a real, non-ideal or the imperfect gas? We have to give a low temperature to it. Like the temperature should be low, but the pressure should be high. It is opposite of the ideal gas. It means we have to give a low pressure to it and the pressure should be high. So when we are giving a low temperature to it, the particles will move near to each other. Here the particles are moving apart from each other, but here the particles will move close to each other. And when the particles move close to each other, they will be having a volume, and when they are having a volume, there will be a force of attraction as well. There the particles were apart from each other, so there will be no force of attraction. But here the particles are moving near to each other, so there will be like more force of attraction, means it will be increased, means there will be a attraction as well as a repulsion. So as we are giving a low temperature, so the kinetic energy would be low, and when the kinetic energy low, it means potential energy is high, and it will be having a volume as well. So what are the conditions? That we have to give a low temperature, but the pressure should be high, and in the result we'll be giving a force of attraction. Kinetic energy will be low, potential energy will be high, and there will be a force of attraction, as well as it will be having a volume. Now the three scientists like Boyle, Charles, as well as Avogadro, they all discussed this gas, ideal gas. They did not discuss this real gas. They all discussed that ideal gas. But there was a scientist, that was a van der Waals, who has given the concept of the non-ideal gas, means a real gas or the imperfect gas. the van der Waals was the scientist that gives the concept of the non-ideal gas. They both are having equations as well. This equation was PV is equal to nRT. Will be proving that as well, and it has another, like, we did not solve this equation. We are just having this equation in our syllabus. So it has also an equation, that is van der Waals equation as well. So we are just going through this. PV is equal to nRT, that is the equation of a ideal gas.